On September 16, 1960, amidst the bustling activity of Portsmouth Naval Shipyard in Kittery, Maine, the keel of a submarine was laid, a vessel destined to carve its name into the annals of American naval history. This was no ordinary submarine. USS Jack, hull number 605, was engineered to stand apart from her contemporaries. Designed as a floating laboratory, USS Jack was set to test a groundbreaking propulsion concept that held the promise of transforming underwater warfare forever. Yet, before she could showcase her capabilities, the shipbuilding program that birthed her would be irrevocably altered by one of the most catastrophic peacetime events in the history of the United States Navy. Originally classified under the Thresher class, this revolutionary design emerged from the ambitious Project Knobsker. In 1956, Admiral Arleigh Burke, then Chief of Naval Operations, initiated a profound inquiry into submarine warfare. He tasked the Committee on Undersea Warfare of the National Academy of Sciences with exploring how cutting-edge technology might redefine the battlefield beneath the waves. The outcome was a visionary blueprint for a new generation of attack submarines, characterized by their ability to dive deeper, operate with unprecedented stealth, and utilize advanced long-range sonar systems. These innovations would empower the Navy to detect Soviet submarines long before the adversary realized they were being pursued. This design, managed under Project SCB-188, marked a monumental leap in submarine technology, rivaling even the advent of nuclear power. The new class retained the reliable S-5W nuclear reactor from its predecessor, the Skipjack class, generating an impressive 15,000 shaft horsepower. Yet, nearly every other aspect of these submarines was nothing short of revolutionary. For the first time, the Navy utilized HY-80 steel to construct pressure hulls. This high-strength alloy, with a yield strength of 80,000 pounds per square inch, enabled operations at depths that would have crushed earlier submarines. While the specifics of test depths remained classified, these vessels could plunge far deeper than the 400-foot limit set by World War II fleet submarines, or even the 750-foot capabilities of early post-war designs. Among the most striking innovations was the colossal bow-mountershire class, was equipped with a 15-foot diameter spherical sonar array designated VQQ-2. This low-frequency detection system could scan for targets at previously unimaginable distances, effectively transforming these submarines into formidable hunter-killers. However, this massive sonar sphere necessitated a radical redesign of the weapon's layout. For the first time since 1941, an American attack submarine would not feature bow-mounted torpedo tubes. Instead, engineers strategically repositioned the 421-inch tubes to midships, angling them outward to port and starboard, thus redefining the very nature of submarine warfare. The sonar sphere found its place at the bow, perfectly positioned to maintain its offensive capabilities while embracing a new era of silent warfare. This was not mere evolution. It was a revolution. The introduction of acoustic stealth was a game-changer, allowing the ship to mount turbines, motors, and other machinery on sound-isolating rafts, suspended delicately from the hull. This innovative raft mounting system effectively silenced the vibrations and noise that once echoed through the metal skin of submarines, creating an almost eerie tranquility within. As the first of its kind, this technology set a new standard, one that would be adopted by every hammer paraded in a near-complete silence that left veteran submariners in disbelief. They could hardly fathom that the vessel was running at full power, for the machinery spaces hummed with a serene quietude. Years of meticulous hydrodynamic research culminated in a streamlined hull that embodied the pinnacle of engineering. External fittings were stripped down to the bare essentials, and the sail, which housed the periscopes and masts, was reduced by nearly 50% compared to the skipjack class. Every contour was designed to glide effortlessly through the depths, minimizing turbulence and maximizing efficiency. The result was a submarine that, despite its larger frame and increased weight, could maintain comparable underwater speeds while evading detection with remarkable ease. At Portsmouth Naval Shipyard, the construction of the USS Thresher, the lead boat of her class, progressed at an impressive pace. Her keel was laid on the 28th of May, 1958, and she was launched into the water on the 9th of July, 1960. By the 3rd of August, 1961, she was commissioned, symbolizing a bold leap into the future of American submarine warfare. Yet, this promising future was cruelly snatched away. On the 10th of April, 1963, the USS Thresher departed Portsmouth for a series of deep-diving tests off the rugged New England coast. Aboard were 129 crew members and civilian technicians, all eager to push the boundaries of their vessel's capabilities. As the submarine conducted post-overhaul trials, testing her systems at ever-increasing depths, an ominous silence cloaked the ocean. Shortly after 9 in the morning, the submarine rescue ship USS Skylark, stationed on the surface, intercepted a garbled transmission from Thresher. The message hinted at difficulties, the crew reporting minor problems while attempting to blow ballast tanks to surface. Then came the chilling final transmission, detailing progressive flooding. At 9:17, a sound shattered the stillness. A violent rupture resonated through the water, the unmistakable noise of a submarine succumbing to the crushing depths. The Thresher had exceeded her crush depth, imploding under the immense pressure of the ocean. In an instant, all 129 souls aboard were lost, their lives extinguished as the pressure hull collapsed. Investigators later uncovered the tragic truth. A brazed pipe joint in the engine room had failed, unleashing a torrent of seawater that shorted out critical electrical systems and triggered a reactor shutdown. Stripped of power and options, the crew found themselves powerless to restart the reactor or operate the ballast tank blow system in time. As the submarine drifted into the abyss, the ocean claimed its prize, swallowing the Thresher whole. The depths of the sea, once a realm of exploration and power, became the final resting place for those who dared to venture into its depths. The tragedy struck the submarine force with an intensity that reverberated through every corner of naval operations, igniting an urgent response that would forever alter the course of submarine construction. In the aftermath, the SubSave program emerged as a beacon of hope and innovation, marking the dawn of an unprecedented quality assurance system in naval architecture. Every component of the pressure hull, each sea-connected system, and every vital piece of equipment was thrust into the spotlight of scrutiny, subjected to a level of inspection and testing hitherto unseen. The Navy, resolute in its commitment to safety, enacted sweeping changes. Brazed joints, once common, were banished from the blueprints, replaced by robust welded connections. The sea blow systems, crucial for emergency surfacing, underwent a complete redesign, ensuring instantaneous activation in the face of danger. The pledge was clear and unwavering. Never again would a submarine succumb to the peril of flooding. In a solemn tribute to the crew lost in this calamity, the class of submarines was renamed the Permit class, a poignant homage to the USS Permit, SSN 594. The remaining vessels under construction were not merely completed, they were meticulously modified to integrate the sub-save standards and the hard-won lessons from the disaster. Among these transformations, 3 submarines, Flasher, Greenling, and Gato, were extended by 13 feet and 9 inches, a significant alteration aimed at incorporating additional safety features and enhancing stability. While these modifications delayed their completion, they heralded a new era of submarines marked by remarkable safety records that would endure for 3 decades. Amidst this wave of innovation, the USS Jack, still taking shape at Portsmouth when the Thresher tragedy unfolded, was destined for a unique legacy. Selected by a coalition of architects, she would serve as the testing ground for an experimental propulsion system designed to tackle one of the most persistent challenges in submarine design, the notorious issue of propeller noise. In the trials of the Skipjack class, sonar operators unearthed a troubling revelation. The 5-bladed propellers emitted a distinctive acoustic signature known as blade rate. Each blade, as it sliced through the turbulent wake generated by the sail and control surfaces, vibrated at a specific frequency, creating underwater sound waves that could traverse vast distances in the ocean. This phenomenon was particularly alarming, as the frequency of these vibrations was directly linked to the submarine's speed and the rate of propeller rotation. A skilled enemy sonar operator could exploit this information, not only detecting a submarine, but also calculating its exact speed and potentially predicting its trajectory. Determined to find a solution, the Navy explored several avenues. One potential fix involved employing a larger propeller with an increased number of blades, designed to interact more gently with the disturbed water. Another option considered was reducing the propeller size to operate entirely beneath the wake zone, though this approach risked cavitation at higher speeds. Ultimately, Jack was chosen to pioneer a third approach: counter-rotating propellers mounted on concentric shafts. This innovative concept promised elegance and efficiency by its own turbine in a direct drive configuration, eliminating the need for reduction gears and thus minimizing the acoustic signature that had plagued previous designs. In this quest for quieter submarines, the USS Jack stood at the precipice of a technological revolution, embodying the Navy's relentless pursuit of excellence in the face of adversity. As she prepared to take to the waters, she carried with her not just the weight of innovation, but the solemn promise to honor those who had come before her. In a groundbreaking advancement of naval engineering, propellers would spin in opposing directions, a design where the aft propeller harnesses the energy generated by the forward propeller's rotational flow. This innovative counter-rotation not only promises to enhance efficiency, but also aims to neutralize torque effects on the submarine's hull, a critical factor in underwater dynamics. The implications of this design extend beyond mere efficiency. Smaller propellers would result in reduced blade rate noise, effectively preserving stealth while maintaining essential thrust capabilities. The experimental system, already showing promise aboard the USS Albuquerque, a diesel-electric research submarine, served as a proving ground for advanced hull forms and propulsion concepts. During its trials, Albuquerque demonstrated remarkable speed improvements, raising hopes for the adaptation of this technology to a full-sized nuclear attack submarine equipped with the S-5W reactor plant. To integrate this experimental machinery into the design, Significant modifications were made to the USS Jack, lengthening the engine spaces by 10 feet and extending the propeller shaft by 7 feet, transformed Jack into a vessel 20 feet longer than her sister submarines, stretching her overall length to 297 feet 5 inches. Such alterations demanded meticulous attention to the submarine's hull strength and diving characteristics. Yet, naval architects were confident that these enhancements would not undermine operational capabilities. April 24, 1963, marked a poignant moment as Jack slid down the ways at Portsmouth Naval Shipyard. The atmosphere was tinged with solemnity, a reflection of the recent tragedy, the loss of the USS Thresher. Grace Wilson Groves, the submarine's sponsor and wife of Lieutenant General Leslie R. Groves, who led the Manhattan Project, symbolized the weight of history and innovation intertwined. The choice of sponsor underscored Jack's role as a vessel of experimentation, a beacon of American technological progress rising amidst the shadows of sorrow. The journey from launching to commissioning would stretch nearly 4 years, a period marked by extensive outfitting and rigorous testing to ensure compliance with submarine safety standards. The pre-commissioning crew devoted themselves to the final construction phases, transforming their vessel into a formidable force ready for service. In an impressive display of camaraderie and competition, while still under construction, Jack's crew clinched the Portsmouth Naval Shipyard Admiral's Trophy for excellence in athletic competition during 1965, marking a significant milestone as the first submarine to earn this prestigious accolade, a point of pride for the men destined to take her to sea. Finally, on March 31, 1967, the USS Jack officially joined the ranks of the United States Navy. Commander Lewis T. Urbanchik Jr. took command during the commissioning ceremony, with Rear Admiral James F. Calvert, a distinguished veteran of World War II, delivering the keynote address. This moment signified not just the birth of a new submarine, but the culmination of dreams, innovation, and the relentless pursuit of excellence in naval warfare. Jack emerged as a testament to resilience, embodying the spirit of progress even in the face of adversity, ready to navigate the depths of the ocean and the annals of history. A veteran once roamed the depths of the Pacific aboard the Gato-class submarine USS Jack, SS-259, a vessel that had etched its mark on history through 9 perilous war patrols, relentlessly sinking Japanese shipping during a time of conflict. Now, the legacy of that formidable name would be reborn, as the new nuclear-powered Jack took to the seas, ushering in a new chapter that would resonate through the Cold War era. This modern marvel, with her specifications echoing the proud lineage of her predecessors, was equipped with modifications that set her apart. At the surface, she displaced 3,440 tons, and submerged, her weight surged to 4,200 tons. The dimensions of her beam stretched to 31 feet and 8 inches, a robust structure housing a crew of 143 officers and enlisted men, each ready to embrace the challenges of the deep. Her speed was remarkable, rated at 15 knots, yet it was within the depths that she revealed her true prowess, exceeding 28 knots, powered by the cutting-edge S5W reactor. This revolutionary engine propelled her through the water with an experimental counter-rotating propeller system, a feat of engineering that promised unparalleled agility and stealth. Armament was a cornerstone of Jack's design. Equipped with 4 21-inch midship torpedo tubes, she was capable of launching the formidable Mark 48 torpedoes, UUM-44A sub-rock anti-submarine missiles, and UGM-84 Harpoon anti-ship missiles. Additionally, her configuration allowed for the deployment of various types of mines, with a maximum weapons load of 23 torpedoes and missiles, or up to 42 mines when tasked with mine-laying operations. Her sensors suite was nothing short of revolutionary. The initial BQQ-2 Bosonar sphere, later upgraded to BQQ-5, combined with the BQR-7 passive conformal hydrophone array and the TB-26 towed sonar array, provided Jack with the capability to detect and track targets at extreme ranges while remaining virtually invisible to enemy detection. This technological edge was further enhanced by the fire control system, which began with the Mark 113 and evolved into the Mark 117, seamlessly integrating sonar data with weapon targeting for precise strikes against adversaries lurking in the depths. Upon her commissioning, Jack was assigned to Submarine Squadron X, stationed at the State Pier in New London, Connecticut. The squadron's mission was clear: maintain a formidable fleet of attack submarines poised to hunt Soviet vessels in the Atlantic and deploy strategically across the globe, ready to respond to any threat. Jack's journey began with a rigorous series of shakedown crews, an exhaustive set of trials designed to push every system to its limits and train her crew to master the submarine under every conceivable condition. The Caribbean became her testing ground, with its deep waters ideal for diving exercises, warm weather facilitating topside operations, and the natural sheltering from Soviet eyes. For weeks, the crew of Jack engaged in a relentless schedule of drills and exercises. The engineering team meticulously monitored the experimental propulsion system, capturing vital data on vibration levels, shaft temperatures, bearing performance, and acoustic signatures. The operations department rigorously tested sonar systems, fire control computers, and weapons handling equipment, ensuring that every cog in the machine was honed to perfection. Meanwhile, damage control parties rehearsed responses to simulated emergencies, a crucial training regimen that prepared each sailor to combat fires, manage flooding, and maintain the vessel's operational integrity during dives and ascents. Through this exhaustive shakedown, the strengths and limitations of Jack's pioneering design came to the fore. Each challenge faced was an opportunity for growth, each success a testament to the ingenuity of her creators and the resilience of her crew. The legacy of the USS Jack, once a symbol of valor in wartime, was now poised to navigate the treacherous waters of a new era, embodying the spirit of innovation and courage that defined the age. The counter-rotating propellers, a marvel of engineering, whispered through the waters, producing significantly less blade rate noise than their conventional counterparts. This innovation was not merely a feat of design, it was a transformative leap towards acoustic stealth. The direct-drive turbines, devoid of reduction gear noise, further enhanced Jack's silent approach, cloaking her presence beneath the waves. Yet, with innovation came complexity. The specialized turbines demanded meticulous maintenance, a commitment that weighed heavily on the engineering crew. The intricate concentric shaft arrangement, adorned with complex seals and bearings, required vigilant monitoring, for any misalignment or wear could unleash a cascade of friction, noise, and potential mechanical failure. In response, the engineering team crafted exhaustive procedures for the inspection and upkeep of this experimental equipment, ensuring that each component functioned in harmony. Despite these hurdles, Jack emerged as a formidable warship, mastering the depths and speeds with an elegance that inspired confidence among her crew. As they navigated the vast ocean expanses, their trust in this unconventional submarine grew, fueled by the promise of her Permit-class quieting features and pioneering propulsion system. Jack became an enigma, a shadow lurking in the depths, capable of approaching targets unheard, gathering intelligence unseen, and striking with an unparalleled ferocity. By the summer of 1968, Jack had successfully completed her rigorous workup period, standing poised for operational deployment. On June 22nd of that year, at State Pier in New London, Commander David G. Smith took command, succeeding Commander Urban Sick. This change of command ceremony signified a pivotal transition, marking the shift from the shakedown phase to full operational readiness. Under Commander Smith's stewardship, Jack was destined to unveil her true potential. In September of 1968, NATO announced Exercise Silver Tower, an ambitious naval exercise that would bring together aircraft and around 200 ships from 9 allied nations: Belgium, Canada, Denmark, the Netherlands, Norway, Portugal, the United Kingdom, the United States, and West Germany. This exercise would serve as a litmus test for NATO's capabilities, featuring destroyers and frigates from the newly formed multinational standing naval force Atlantic. The scenario unfolded with an imagined threat to Norway, emanating from a hostile nation termed Orange. This exercise would rigorously assess NATO's ability to defend its northern flank against a coordinated attack. Jack was tasked with a critical role: to embody an Orange submarine, tasked with penetrating NATO's defenses and striking high-value targets, simulating the menacing threat posed by Soviet submarines during a real conflict. As Exercise Silver Tower commenced in October of 1968, Jack transformed into a ghost, slipping beneath the North Atlantic's surface. Her Permit-class quieting and cutting-edge propulsion system rendered her virtually undetectable, a phantom in the depths, silently executing her mission while the world above remained blissfully unaware of her presence. The stage was set for a demonstration of stealth and strategy, where every movement would echo the delicate balance between power and silence in the theater of naval warfare. The vast expanse of the ocean, a silent battleground, bore witness to a formidable display of naval warfare capabilities. The anti-submarine forces, equipped with an extensive arsenal of sensors, hull-mounted sonars, towed arrays, and sonobuoys deployed from aircraft, prepared for a confrontation that would test the limits of their technology. Specialized hunter-killer groups patrolled the waters, vigilant and ready. Yet none could consistently track the phantom that was the submarine known as Jack. With the precision of a predator, Jack stalked the vulnerable logistics vessels, the lifelines of any NATO fleet in times of conflict. These underway replenishment groups, often overlooked, were essential for sustaining operations at sea. Jack's sonar operators, adept in their craft, meticulously monitored the merchant ships and their escorts, calculating firing solutions while simulating torpedo attacks. The ocean remained oblivious to the lurking threat, as Jack claimed its targets without detection, a ghost in the depths. Then, the focus shifted to the exercise's crown jewel, a large, fast carrier task force centered around a state-of-the-art aircraft carrier. This floating fortress, steaming at high speed, was encircled by a formidable screen of destroyers and frigates, strategically positioned to thwart any submarine incursions. Their sonars swept the ocean, forming an intricate web of acoustic detection zones designed to be impenetrable. Yet, Jack, with its finely tuned instincts, found the gaps in this seemingly flawless defense. Maneuvering into an optimal attack position, Jack exploited thermal layers that distorted sound waves, rendering enemy sonars ineffective. The counter-rotating propellers turned with near silence, minimizing blade rate noise to a mere whisper in the ocean's depths. As the fire control team calculated weapon solutions, the simulation of torpedoes launched at the carrier and its protective escorts unfolded. The exercise referees, tasked with assessing the attack, ruled it a resounding success. The carrier, a symbol of naval power, had been sunk. In the aftermath of the Silver Tower exercise, as participating ships converged at Rosyth Dockyard in Scotland for the debriefing, Jack's remarkable performance garnered special recognition. With a staggering simulated sinking tonnage of 319,000 displacement tons, Jack eclipsed the achievements of legendary submarines from World War II. To grasp the magnitude of this accomplishment, consider that the three top-scoring American submarines of that era collectively sank just over 293,000 tons throughout the entire conflict. USS Flasha accounted for 100,231 tons, USS Rasha for 191,919 tons, and USS Tang for 93,824 tons. In a single exercise, Jack had surpassed what took these storied vessels an entire war to achieve. The ramifications of Jack's performance were profound, echoing through the corridors of naval strategy. This modern nuclear attack submarine, meticulously designed and expertly operated, had showcased its potential to dominate the undersea battlefield. The potent combination of deep diving capability, advanced bow-mounted sonar, sound-dampening machinery, and Jack's experimental propulsion system forged a weapon platform capable of hunting with impunity while remaining nearly undetectable. In this high-stakes game of cat and mouse, NATO's anti-submarine forces found themselves outmatched, their defenses rendered ineffective against Jack's prowess. Had Jack been a Soviet submarine, the exercise would have concluded with multiple NATO vessels resting on the ocean floor, a stark reminder of the shifting tides of naval warfare. The balance of power in the depths had irrevocably changed, heralding a new era in undersea combat. On a momentous day, November 3, 1968, the submarine newsletter Dolphin chronicled a remarkable milestone aboard the USS Jack. Deep beneath the Atlantic waves, the atmosphere was charged with anticipation as electrician's mate Master Chief Edward J. Lyons marked his 5th year of unwavering service by receiving a promotion to Master Chief Petty Officer, the pinnacle of enlisted ranks in the Navy. This celebration was not merely a personal achievement. It symbolized the enduring legacy of commitment and resilience aboard Jack, as Lyons stood among the last 3 remaining plank owners from the submarine's inaugural launch in 1963. These men, whose journeys intertwined with the steel hull of Jack, had witnessed every triumph and challenge since its birth. The ability to conduct a promotion ceremony while submerged showcased the confidence and professionalism that defined the crew. It was a testament to their training, skill, and the seamless cohesion that allowed them to thrive in the dipyard for a critical 4-month post-shakedown availability. This period was essential for engineers, who meticulously examined the experimental propulsion system after extensive operations, ensuring that every component was scrutinized and optimized. While the counter-rotating propellers had performed admirably during the exercises, the intricate shaft seals and bearings demanded careful attention. After a thorough inspection and necessary adjustments, Jack re-emerged from the shipyard in March 1969, ready to embrace new challenges. Almost immediately, Jack participated in Exercise Springboard, a rigorous training operation set against the backdrop of the Caribbean's warm, azure waters off the coasts of Puerto Rico and the Virgin Islands. This idyllic environment became the proving ground for intensive weapons training. The submarine's weapons department pushed the torpedo tubes and fire control systems to their limits, launching exercise torpedoes at target submarines and surface vessels. The fruits of their labor were evident, as Jack's outstanding performance during Springboard earned the weapons department the coveted Battle Efficiency E Award, a recognition of unparalleled standards in fire control excellence. As 1969 progressed, the USS Jack received orders for a top-secret special operation, cloaked in mystery and intrigue. The details of the mission remained classified, but it undoubtedly pushed both the submarine and its crew to their absolute limits. Whatever challenges they faced and overcame during this deployment left an indelible mark on the Navy's leadership. Admiral Thomas H. Mora, the Chief of Naval Operations, personally endorsed a letter from the Secretary of the Navy, bestowing upon Jack the Meritorious Unit Commendation. The citation articulated the gravity of their achievements, commending the crew for their meritorious service during a demanding and critical independent submarine operation in 1969. The successful completion of this mission yielded significant results, vital to the national defense of the United States. The commendation highlighted that these accomplishments were realized through the professional skills, resourcefulness, and unwavering teamwork of the officers and men aboard the USS Jack. Their dedication to executing a challenging assignment not only brought honor upon themselves, but also reflected the esteemed values of the United States Naval Service. Authorization was granted to all personnel who served aboard the submarine Jack during a classified operation, allowing them to don the Meritorious Unit Commendation ribbon. The deliberate ambiguity of this citation concealed a deeper narrative, one rooted in the shadowy world of submarine warfare during the tumultuous years of the Cold War. World War submarine operations were not merely about combat. They were intricately woven into the fabric of intelligence gathering, tracking Soviet submarines, and probing enemy defenses. Jack, with her unique capabilities, was perfectly suited for missions demanding stealth and endurance. The experimental propulsion system, while temperamental and challenging to maintain, provided Jack with an acoustic edge that could mean the difference between success and catastrophic failure in hostile waters. On June 26, 1969, Jack embarked on a mission that, while less clandestine, held equal significance. The submarine was tasked with testing the performance of a Mark 16 torpedo under combat conditions. The Navy had selected the decommissioned World War II destroyer escort USS Snowden, designated DE-246, as the target. Stricken from the Naval Register and slated for disposal, Snowden's fate was sealed. Utilizing her as a target would allow the Navy to validate the lethality of the Mark 16 torpedo, armed with a live warhead, as it sought to sink a surface combatant. As Jack glided toward the target area, her sonar expertly tracked the movements of Snowden. The fire control team meticulously calculated the firing solution, factoring in the destroyer escort's position, course, and speed with precision. At the moment deemed perfect, Jack unleashed a single Mark 16 torpedo. The weapon ran true, striking Snowden with devastating accuracy and detonating upon impact. The explosion tore through the hull of the destroyer escort, sending her to the depths of the sea. This test confirmed the torpedo's warhead and fusing system functioned flawlessly, delivering crucial data that would influence future submarine operations. Fast forward to the summer of 1970, Jack found herself engaged in midshipman training at the United States Naval Academy in Annapolis, Maryland. It was during this period that the commander of Submarine Force Atlantic bestowed upon Jack the Battle Efficiency E Award, a prestigious recognition granted to the most combat-ready submarine in the squadron. This accolade was based on rigorous assessments of performance in weapons handling, engineering operations, damage control, and overall operational readiness. The simultaneous achievement of this award while conducting training operations showcased Jack's remarkable ability to sustain peak performance, even amidst educational commitments. Midshipmen who stepped aboard Jack bore witness to a submarine operating at the pinnacle of professionalism. By early 1971, Jack had sustained continuous operation for nearly 4 years. The intricate systems, including the experimental propulsion system and the S-5W reactor, necessitated thorough inspection and comprehensive overhaul. On February 11, 1971, Jack arrived at Portsmouth Naval Shipyard, ready to undergo an extensive 12-month overhaul. Shipyard workers prepared to open the reactor compartment, poised to inspect the core and determine the necessity of refueling. This moment marked not just a routine maintenance check, but a critical juncture in the submarine's storied career, heralding the next chapter in her legacy. The meticulous examination of counter-rotating propellers, specialized turbines, and the intricate arrangement of concentric shafts unfolded in the heart of the shipyard. Every system underwent rigorous testing, every component scrutinized under the watchful eyes of engineers dedicated to excellence. By early 1972, as the overhaul approached its culmination, the Atlantic Fleet's Operational Reactor Safeguards Examining Board arrived, poised to conduct a thorough inspection. This esteemed board was established to ensure that each nuclear submarine adhered to the stringent standards of reactor safety, a mission of paramount importance in an era defined by tension and uncertainty. The inspectors engaged with crew members, delving into their experiences, observing operational drills, and meticulously reviewing maintenance records. Their inquiries extended to the engineering team, whose knowledge was put to the test, ensuring that every facet of the submarine was not only operational, but exemplary. Upon the inspection's conclusion, the accolades flowed. Jack received the highest commendation from the Fleet Command, a testament to both the shipyard's craftsmanship and the crew's unparalleled expertise. On July 22, 1972, a pivotal transition occurred as Commander Thomas F. Weiner assumed command, relieving Commander Smith. Almost immediately, Weiner charted a course for the Mediterranean Sea, embarking on a deployment that would place Jack in one of the Cold War's most strategically significant arenas. The submarine traversed the Atlantic, navigating through the Strait of Gibraltar, and entered the Mayan Ostrom, a region rife with geopolitical tension. In this theater, the Soviet Navy had established a steadfast presence, deploying the 5th Escadra, a formidable squadron comprising submarines, surface combatants, and intelligence collection ships. American submarines, including Jack, patrolled the waters, vigilantly monitoring Soviet maneuvers to ensure that the U.S. 6th Fleet's carrier battle groups could operate unimpeded. A striking photograph from March 6, 1972, captures Jack off La Spezia, Italy, gliding majestically on the surface amidst calm seas. The image showcases the submarine's elongated hull, a direct result of experimental propulsion modifications. The sail rises with an elegant, streamlined profile, housing essential instruments such as periscopes, radio masts, and radar antennas. The sleek hull embodies the Permit-class design's commitment to hydrodynamic efficiency and noise reduction, a crucial factor in underwater warfare. From October 1975 to January 1977, Jack underwent another comprehensive overhaul at the Portsmouth Naval Shipyard. This extensive period included a complete main engine overhaul and a critical nuclear refueling. The replacement of the reactor core was an intricate operation, demanding precision in the handling of radioactive materials and meticulous reassembly of the reactor systems. The shipyard extended the overhaul, ensuring that every system met the rigorous sub-safe standards mandated by the Navy. During one particularly challenging trial in State 6 Seas, conditions described as very rough, a surge of seawater coursed down the induction mast, a formidable pipe designed to supply air to the diesel generators and facilitate ventilation while snorkeling. The water overwhelmed the induction sump, engineered to collect and drain minor amounts of seawater, revealing the relentless challenge. In the depths of the ocean, where silence reigns and the stakes are immeasurable, every test, every trial, and every triumph shapes the legacy of a vessel and its crew, forging them into guardians of the deep. A deluge of seawater surged into the battery breaker room, a stark reminder of the perilous dance between nature's might and human technology. Seawater, mingling with electrical systems, forged a volatile cocktail that ignited chaos. An explosion erupted, flames licking at the confines of the vessel. In the face of disaster, the crew sprang into action, their rigorous damage control training kicking in as instinct. They swiftly isolated the affected compartment, wielded portable extinguishers with precision, and engaged firefighting systems, all while securing electrical power to thwart any further explosions. This incident laid bare the inherent dangers of submarine operations, but it also underscored the critical importance of relentless training and preparedness. Despite the harrowing ordeal, the submarine Jack emerged triumphant from her sea trials, proceeding to Groton, Connecticut. Between 1977 and 1978, Jack undertook sound trials to validate her distinctive acoustic signature, achieved certification for the formidable Mark 48 torpedo, and participated in a series of demanding training missions. Yet, off the coast of North Carolina, adversity struck again. The submarine experienced a catastrophic main engine failure, a direct consequence of the intricate direct drive system, which faced stresses that conventional geared turbines could withstand. Helpless and without power, Jack found herself in need of a tow back to Groton for essential repairs. This incident illuminated the ongoing challenges tied to maintaining the experimental propulsion system, a testament to the complexities of modern submarine engineering. On June 2, 1974, Commander Richard K. Westfall took the helm, succeeding Commander Weiner. His leadership would span nearly 4 years, concluding on April 8, 1978. Commander Richard H. Hartman then took charge, steering Jack until October 31, 1981. Under Hartman's command, Jack embarked on numerous deployments, embodying the relentless operational tempo that defined the Cold War submarine force. A peculiar incident unfolded on April 27, 1981, while Jack was deployed in the Mediterranean near Alexandria, Egypt. Positioned alongside the USS Trenton, a formidable amphibious transport dock, the submarine faced unexpected challenges. Heavy swells, a rarity in the sheltered harbor, caused both vessels to surge against their mooring lines. Despite the crew's diligent efforts to maintain a safe distance, a collision occurred, resulting in minor damages, scraped paint, and bent railings. This episode served as a stark reminder of the difficulties faced when maneuvering submarines in confined harbors amid adverse weather conditions. On October 31, 1981, Commander David J. Beatty assumed command, marking the beginning of the longest single command tour aboard Jack. Beatty would guide the submarine for nearly 5 years, until September 4th, NURJ for the final years of operational service. As September 1982 approached, Jack returned to the Portsmouth Naval Shipyard for an unprecedented 27-month overhaul, the most extensive in the submarine's storied history. Each moment in this timeline weaves a narrative of resilience, innovation, and the ever-present challenges of underwater warfare, echoing the commitment of those who serve beneath the waves. The ambitious overhaul of the submarine would stretch over 2 years, a monumental task that would see the shipyard essentially reconstructing key components of the vessel. Each facet of the submarine's core would undergo meticulous attention. The reactor would receive a fresh supply of fuel. The propulsion system would be re-engineered, sonar systems would be upgraded, and a myriad of enhancements would be implemented. This extended timeline was not merely a reflection of the intricate nature of the work, but also a testament to the Navy's unwavering dedication to keep the Permit-class submarines operational, even as they aged gracefully in service. In April 1983, while Jack was nestled in dry dock, an unforeseen casualty occurred. Official records remained vague regarding the specifics of the incident, yet any mishap during such a critical overhaul phase brought with it a cascade of complications, necessitating thorough inspections to ensure that no lasting damage lingered beneath the surface. The engineering team, alongside shipyard workers, swiftly tackled the issue, ensuring that the overhaul process could continue unabated. By late 1984, Jack emerged from the extensive refurbishment, her systems modernized, and her experimental propulsion system revamped once more. The submarine was ready to resume operations, yet both Jack and the Permit class faced the inevitable march of time. Newer submarines, such as the Sturgeon class and the first of the Los Angeles class, came equipped with enhanced capabilities and more dependable propulsion systems, prompting the Navy to strategize for the eventual retirement of the Permit-class fleet. Despite her years, Jack still exhibited the prowess that had defined her legacy. She actively participated in NATO exercises, conducted deployments across the Mediterranean, and maintained a state of readiness for any contingency operations that might arise. In September 1988, Jack was operating alongside NATO forces in the frigid waters off Norway. A photograph from that deployment immortalizes Jack alongside the submarine tender USS L.Y. Spear, designated AS-36. Just outboard of Jack lay the British nuclear submarine HMS Torb, while 2 small German diesel submarines, U-12 and U-21, secured themselves alongside the tender on its port side. This image encapsulated the multinational collaboration inherent in NATO submarine operations, a vivid reminder of the unity amongst Allied navies. On September 4, 1986, Commander Lonnie D. Butler assumed command of Jack, succeeding Commander Beatty. Under Butler's leadership, the submarine navigated through her penultimate years of service, maintaining operational readiness while the specter of decommissioning loomed ever closer. The tide of history shifted dramatically when, on November 22, 1988, Commander Bruce L. Bullough took the helm as Jack's final commanding officer. Bullough's leadership came at a pivotal juncture, as the Cold War, which had shaped the submarine's entire operational existence, approached its culmination. In November 1989, a momentous event unfolded. The Berlin Wall fell. Crowds of jubilant Germans surged forward, tearing down the barrier that had divided their city for 28 long years, a powerful symbol of a world on the brink of transformation. The Soviet Union, a behemoth once feared and revered, found itself in a state of disarray, its political foundations crumbling under the weight of economic exhaustion. The monumental military standoff that had fueled the frantic pace of submarine innovation for 40 long years was drawing to an unexpected close. Rather than the cataclysmic nuclear confrontation that had haunted the world's collective consciousness, the Cold War unraveled quietly, surrendering to the peaceful dissolution of the communist bloc. For the United States Navy's submarine force, this seismic shift heralded a new era filled with profound transformations. The fleet had been meticulously crafted to counter the formidable Soviet submarine threat. At the zenith of the Cold War, the Soviet Navy boasted an astounding fleet of over 200 nuclear-powered submarines. These included terrifying ballistic missile boats capable of raining destruction upon American cities, and attack submarines engineered to hunt down U.S. aircraft carriers and sever vital Atlantic supply lines. In this high-stakes theater, America's Soviet leviathans, to track their movements, and to ensure that, should the drums of war sound, American forces would command the oceans. As the specter of the Soviet threat began to fade, however, the Navy found itself grappling with an unsettling reality. Budget cuts loomed large, and force reductions became inevitable. The Permit-class submarines, once the pride of the fleet and now in their third decade of service, emerged as prime candidates for early retirement. Their groundbreaking technology had set benchmarks when they were commissioned, but they were now eclipsed by the advancements of their successors. The Sturgeon class, introduced between 1967 and 1975, featured enhanced sonar and weapon systems that outpaced their predecessors. Meanwhile, the Los Angeles class, which first set sail in 1976 and continued its production well into the mid-90s, offered remarkable speed, deeper diving capabilities, and cutting-edge electronics. Maintaining a diverse fleet of submarines was a drain on resources, and the Navy could ill afford to operate vessels from 3 distinct classes simultaneously. Thus, the decision to decommission the Permit class evolved slowly yet inexorably. USS Dace, commissioned in 1964, was the first to bow out, officially decommissioning on December 2, 1988. This marked the beginning of a rapid succession of retirements as the Navy streamlined its submarine force to align with the new post-Cold War reality. By the middle of 1992, only 2 Permit-class submarines remained in commission, USS Greenling and USS Garto. Their imminent decommissioning would signal the final chapter for a class that had set the template for all subsequent American attack submarine designs. Then came the turn of USS Jack in 1990. After more than 23 years of steadfast service, a legacy marked by the rigors of Exercise Silver Tower and covert operations that garnered meritorious unit commendations, the time had come. Having earned numerous battle efficiency awards and undertaken deployments across both the Atlantic and the Mediterranean, Jack had proven the viability of its experimental propulsion system despite its inherent challenges. Yet, with the end in sight, orders arrived for decommissioning. This solemn process commenced with the crew meticulously conducting a final round of equipment inspections and systematic shutdowns. Reusable equipment was carefully extracted, destined to breathe new life into submarines that would continue to serve, marking the end of an era that had defined American undersea warfare for decades. The reactor, once a powerhouse of energy, would soon be silenced, its core stripped of fuel, the spent nuclear remnants meticulously prepared for transport to the Naval Reactor Facility nestled in Idaho. On a significant day, July 11, 1990, the USS Jack, a vessel that had prowled the depths of the Atlantic, was officially decommissioned. This momentous occasion unfolded at a ceremony graced by former crew members and Navy officials, marking the end of an era. The submarine, once a formidable hunter, had participated in exercises that rattled NATO forces and conducted clandestine operations vital to national defense. Now, it bore a new identity, Jack, a hull stripped of its glory, awaiting its final fate. Jack was towed to the Bremerton Naval Shipyard in Washington State, joining a fleet of other decommissioned nuclear submarines, all awaiting their turn under the Nuclear-Powered Ship and Submarine Recycling Program. This initiative, established at the Puget Sound Naval Shipyard, aimed to dismantle these vessels with utmost safety and environmental consideration, recovering valuable materials while addressing the pressing concerns surrounding nuclear waste management. The end of the Cold War had left an overwhelming number of submarines requiring disposal, and this program was a response to that challenge. The recycling process unfolded with a methodical precision, each step strictly regulated to ensure safety and environmental protection. Workers embarked on the daunting task of removing all remaining equipment, from weapon systems to electronics, anything that could be repurposed or necessitated special handling. With careful deliberation, the submarine's hull was severed into sections. The forward section, housing crew spaces, the reactor compartment containing the defueled nuclear reactor and its associated systems, and the aft section, where the engine room and propulsion systems lay dormant. Each segment demanded unique handling protocols. The forward and aft sections were transformed into scrap metal, recycled for commercial use, breathing new life into the remnants of a proud vessel. However, the reactor compartment posed a different challenge. Even in its defueled state, it harbored components that had been exposed to radiation, remnants that would remain hazardous for centuries. The Navy's solution was both ingenious and cautious. They sealed the reactor compartment into a waterproof, structurally sound package, ready for transport. This journey would take the compartment by barge and specialized multi-wheeled trailers to the Hanford site in Washington State. Hanford, a place steeped in history, had once been a key player in the Manhattan Project during World War II, producing plutonium for atomic weaponed nuclear submarines. At Hanford, workers excavated long trenches into the arid desert soil, methodically placing the sealed compartments in neat rows. Each filled trench was carefully covered with earth, sealing away the remnants of a powerful past. The compartments, designed to withstand the test of time, were expected to retain their structural integrity for more than 6 centuries. In this desolate landscape, the legacy of these submarines would be interred, a quiet testament to the complexities of technology, war, and the enduring impact of human innovation. As the last trench was filled, the echoes of their missions faded into the sands of time, leaving behind only the whispers of history. In the depths of history, a remarkable chapter unfolds, one marked by innovation, secrecy, and the relentless pursuit of maritime superiority. The story begins with a bold endeavor to safely isolate radioactive materials from the environment. a mission that would ultimately lead to the completion of the recycling of the Jack on June 30, 1992. This submarine, laid down on September 16, 1960, and launched on April 24, 1963, would be commissioned on March 31, 1967. Yet, despite its storied beginnings, it now exists only as a sealed reactor compartment, buried beneath the earth at Hanford, resting alongside the remnants of numerous other Cold War submarines. The physical remnants of this once proud vessel are limited to its sail, preserved at the Puget Sound Naval Shipyard, a solemn reminder of the contributions made by the Permit class. Here, Jack's unit insignia and commemorative items are safeguarded by museums and cherished by former crew members, bearing witness to a legacy that transcends time. At the heart of Jack's identity was its experimental propulsion system, a marvel of engineering that set it apart from its contemporaries. Navy engineers meticulously documented every facet of this unique system before the submarine's destruction. They delved into the intricacies of the counter-rotating propellers, the direct drive turbines, and the concentric shaft arrangement, analyzing the specialized components that defined its performance. Over 23 years of operations, they compiled a wealth of performance data, encompassing acoustic measurements, maintenance records, and casualty reports. The findings were clear and unequivocal. While the counter-rotating propellers aimed to minimize blade rate noises, the complexities and maintenance challenges inherent in the system overshadowed its acoustic benefits. In a pivotal decision, the Navy opted for an alternative solution on other Permit-class submarines and subsequent designs. These large, scythe-shaped propellers, meticulously engineered to engage gently with the wake from the sail and control surfaces, achieved comparable noise reduction without the burdensome mechanical intricacies. As the years progress, offering even greater levels of acoustic stealth, Jack's experimental propulsion system, though ultimately sidelined, contributed invaluable insights to the Navy's understanding of submarine propulsion, shaping the trajectory of future design decisions. Yet, the legacy of Jack extends far beyond the realm of counter-rotating propellers. This submarine validated the Permit-class design concept. The innovative combination of HY-80 steel construction, bow-mounted sonar, sound-rafted machinery, and deep-diving capability proved to be extraordinarily effective. Exercise Silver Tower demonstrated the formidable prowess of a well-designed nuclear attack submarine, capable of dominating the undersea battlefield, tracking and engaging targets that remained blissfully unaware of their hunter. The covert operations that earned meritorious unit commendations underscored the remarkable capabilities of these submarines, enabling them to undertake intelligence gathering and strategic missions unattainable by surface ships or aircraft. The Permit class established a blueprint for American attack submarines that would endure for the next 50 years, weaving a narrative of innovation, triumph, and a relentless quest for supremacy in the depths of the ocean. The evolution of naval warfare is often marked by technological advancements and strategic innovations. Yet few vessels encapsulate this transformation as profoundly as the submarines of the United States Navy. From the Sturgeon class, which retained the bow sonar and midship torpedo tubes, to the sophisticated machinery that defined its operation, each iteration has built upon the foundations laid by its predecessors. The enhancements in sensors and weaponry were not mere upgrades. They were a testament to an ever-evolving understanding of undersea combat. Transitioning into the Los Angeles class, submarine design accelerated dramatically. These vessels not only boasted increased speeds, but also featured electronics that redefined naval capabilities. The leap from the Sturgeon to Los Angeles was not just an improvement, it was a revolution in underwater warfare. The Seawolf and Virginia classes, emerging in the latter decades of the 20th century, continued this legacy with remarkable innovations, such as pump jet propulsion and advanced stealth features. Modular mission systems became the norm, yet the architectural principles that guided their design traced an unbroken line back to the pioneering days of Project Nobsker and the Permit-class submarines. Amid these technological advancements, the legacy of Jack, a distinguished member of the Permit class, stands out. Over 23 years, hundreds of dedicated men served aboard her, each contributing to the storied history of the submarine. 8 commanding officers navigated the complexities of her mission, each leaving an indelible mark on her journey. Under the leadership of Lewis T., the submarine was commissioned and faced the rigorous shakedown period, a critical test of her capabilities. Commander David G. Smith took the helm during the pivotal exercise Silver Tower, a moment that remains etched in the annals of naval history, alongside covert operations that unfolded in 1969. The subsequent commanders, Thomas F. Weiner, Richard K. Westphal, Richard H. Hartman, David J. Beatty, Lonnie D. Butler, and Bruce L. Buller, each played vital roles in ensuring operational excellence. They steered Jack through numerous deployments and overhauls, adapting to the shifting tides of the strategic landscape. Crew members, from the engineers who meticulously maintained the experimental propulsion system to the sonar operators who tracked elusive targets, shared a unique bond forged in the depths of the ocean. The torpedo men, with their precise loading of weapons, and the cooks, who nourished the crew during lengthy deployments, all contributed to a singular experience aboard the only submarine in the Permit class, distinguished by its counter-rotating propellers. Many of these sailors continued their naval journeys aboard other submarines or transitioned to various assignments. Others left the Navy, channeling the discipline, technical expertise, and camaraderie honed aboard Jack into civilian careers, forever marked by their time beneath the waves. Periodic crew reunions allowed these veterans to reconnect, weaving together the threads of shared memories and experiences that defined their service. The Cold War submarine force operated under a veil of secrecy, a necessity that cloaked their operations in mystery. For decades, the missions undertaken by these submarines remained classified, leaving the public largely unaware of their deployments, the intelligence gathered, and the critical roles they played. While this secrecy was vital for operational security, it often meant that the contributions of submarine crews went unrecognized. Exercise Silver Tower, a peacetime NATO drill, was one of the rare moments when their efforts could be acknowledged publicly. The meritorious unit commendations awarded to Jack signified significant accomplishments, yet the specifics remained shrouded in confidentiality. The crew understood the magnitude of their achievements, but the shadows of secrecy barred them from sharing their triumphs with families and friends, leaving an enduring legacy known only to those who served aboard her. In the depths of the Cold War, a silent yet fierce battle unfolded beneath the surface of the ocean. American attack submarines engaged in a relentless pursuit of their Soviet counterparts, a game of stealth and strategy that was as much psychological as it was tactical. These submarines, equipped with cutting-edge technology, ventured into the vast expanse of the sea, meticulously tracking Soviet ballistic missile submarines. Each acoustic signature recorded, every patrol area mapped, became a vital piece of intelligence in a high-stakes chess match that could determine the fate of nations. Weeks, even months, were spent submerged, cloaked in secrecy, as American submarines maintained close proximity to their Soviet rivals, while ensuring they remained undetected. The stakes were monumental. Detection could lead to an immediate confrontation that would reverberate through the geopolitical landscape. The tension was palpable, with the weight of responsibility resting heavily on the crew. A failure of equipment could mean the end of the mission, the abrupt severing of vital contact, and the loss of invaluable intelligence. Yet it was this very intelligence that shaped American strategic planning, providing a critical edge in the looming specter of conflict, the contribute that kept the world's superpowers in check. Jack, with her advanced permit-class capabilities and experimental propulsion systems, stood out as a formidable asset in covert operations and intelligence gathering. The significance of her missions was underscored by the recognition from the highest echelons of naval command. When Admiral Thomas H. Moore, the Chief of Naval Operations, personally signed the meritorious Unit Commendation Citation in 1969, it became evident that Jack's accomplishments resonated far beyond the confines of her hull. As the Cold War drew to a close, the veil of secrecy surrounding these submarine operations began to lift. Historians, granted access to previously classified documents, unearthed narratives from former submarine commanders who shared their harrowing experiences of tracking Soviet submarines. Although the complete scope of these operations remained shrouded in secrecy, enough emerged to illuminate the critical role that American attack submarines played in deterring Soviet aggression and maintaining naval superiority across the globe. The decommissioning of the USS Jack in 1990 coincided with a pivotal moment in history, the final phase of the Soviet Union's collapse. Just a year later, in August 1991, hardline communists attempted a coup against the beleaguered leader Mikhail Gorbachev. The coup's failure only hastened the disintegration of the Soviet state, culminating in the formal dissolution of the Soviet Union by December of that year, giving rise to 15 independent republics. The Russian Federation inherited the remnants of the once mighty Soviet Navy, including submarines, surface vessels, and naval bases. However, economic turmoil crippled the Russian military's ability to maintain these assets, leading to the decommissioning of hundreds of Soviet-era nuclear submarines in the ensuing decade, a legacy marred by environmental hazards as the nation grappled with the safe disposal of radioactive materials. Meanwhile, the United States confronted its own challenges, albeit more manageable. The American Navy systematically decommissioned older Permit-class, Sturgeon-class, and early Los Angeles-class submarines as newer, more advanced vessels entered service, marking the evolution of naval warfare in a world forever altered by the shifting tides of power and influence. The story of the Jack and her comrades is a testament to an era defined by secrecy, strategy, and the unyielding quest for supremacy beneath the waves. The submarine recycling program emerged as a meticulous endeavor, a testament to human ingenuity and responsibility. It ensured the careful disposal of decommissioned vessels, managing radioactive materials with precision while adhering to stringent environmental standards. By the dawn of the 21st century, this initiative had successfully recycled over 100 nuclear submarines, a remarkable feat that demonstrated the possibility of safely managing the enduring legacy of the Cold War. In this intricate tapestry of history, the story of USS Jack unfolds, transcending the narrative of a single submarine. Jack embodies the fierce arms race of the Cold War, a period marked by relentless technological advancements and the unwavering commitment of the men tasked with operating these formidable machines amidst perilous conditions. Originally conceived as an experimental vessel, Jack was designed to test innovative counter-rotating propellers, a groundbreaking concept that promised to revolutionize underwater propulsion. As Jack evolved, it transformed into a formidable warship, showcasing its prowess during Operation Silver Tower and various classified missions that would remain shrouded in secrecy for decades. The technological supremacy of American submarines was firmly established, reflecting years of dedicated training and innovation. Jack's service concluded with the waning of the Cold War, paving the way for a new generation of submarines while leaving behind invaluable operational data that would inform future designs. The Permit-class submarines, including Jack, served as a crucial link between the pioneering nuclear submarines that first validated the concept of nuclear propulsion and the advanced attack submarines that would dominate naval operations in the late Cold War and beyond. The innovations in deep diving, acoustic stealth, and long-range sonar developed during this era laid the groundwork for the capabilities of the Sturgeon and Los Angeles classes. Without these foundational advancements, the modern Virginia-class submarines entering service today would not exist in their current form. For 23 years, from its commissioning in 1967 to its decommissioning in 1990, USS Jack traversed thousands of miles, engaging in numerous deployments and participating in countless exercises. The missions undertaken during this time, many still classified, speak to the submarine's significant role in maintaining American naval superiority during some of the Cold War's most tumultuous decades. Although the experimental propulsion system that made Jack unique ultimately proved too complex for operational use, the submarine itself demonstrated remarkable capability. The professionalism of Jack's crew shone through their numerous battle efficiency awards and meritorious unit commendations, affirming the effectiveness of the Permit-class design and its contribution to naval dominance. Today, only echoes of the past remain. Memories, photographs, documents, and the sealed reactor compartment at Hanford stand as silent witnesses to a storied legacy. Former crew members occasionally gather, united by their shared experiences aboard the submarine with its counter-rotating propellers, reflecting on their service and the indelible mark it left on their lives. Naval historians delve into Jack's significance within the broader narrative of Cold War submarine operations, mining the lessons learned from its experimental propulsion system to inform contemporary submarine design discussions. In this way, the legacy of USS Jack persists, a poignant reminder of the intricate interplay between history, technology, and the relentless pursuit of progress. Buried beneath the arid expanse of the Washington Desert lies a reactor compartment, a ghostly remnant of a time when Jack traversed the shadowy depths of the Atlantic. This sealed chamber stands as a testament, a solemn tribute to the Cold War submarine force and the courageous men who dedicated their lives to the silent service. Its presence evokes a sense of reverence, encapsulating the untold stories of bravery and sacrifice that echo through the ages. As the sands shift, this monument will endure, a silent guardian of history, preserving the legacy of those who ventured into the abyss, forever bound to the mysteries of the ocean's depths.